Hello, calculus. I am excited to pretend to see you again, even though I'm just staring at my computer. I miss you all. For day 2 of calculus in 7.1, we are working on the accumulation process of integration. So this is pretty much just a kind of watch and see version here. Yeah, that's not important too. So if we're looking at the area underneath the parabola from -2 to 2, we can think of it as kind of this picture. Think of this becoming animated here. We have the left bound up to the right bound, so we can kind of start with this mini rectangle, and as we drag it across, that area gets bigger and bigger and bigger and bigger and bigger, which is kind of shown here in the pink. And finally, the height of that triangle gets bigger and then gets smaller, but that accumulation of those areas, if we think of all of those mini rectangles added together, that then becomes the limit process as we are adding together all of those tiny little area rectangles. We then get the area of the whole curve. So that is why the limit process is still involved here in this chapter 7. So for the most part here, I'm just going to go through some of the tougher problems in chapter 7. I pulled these screenshots from Calc chat to kind of explain. I'm going to start with number 25 in the homework from 7.1. In number 25, you need to first find the area of intersection. So here's the graph. If I take the parabola and intersect it with the linear function, we get all of our x's to both sides. We can factor and solve. The intersection is at -2 and 1. The y values really do not matter in this whatsoever. So as we kind of drag these little blue boxes here, notice that the blue boxes go from -2x up to +1x. So this is going to be a derivative with respect to x, a dx function. We're going from the left to the right. Yes, the bars are vertical, but we are asking what are the bars connected to as home base. That home base is the x-axis, so that's why it's a dx function. Okay, then I color-coded this, the top function minus the bottom function. We have the linear minus the parabola. You need to simplify before you take the integral, so we can simplify that to -x squared minus x plus 2, and then take the integral of that, use your bounds with respect to x, and you can get that area in here. So there's just that basic review of how we get an area between two curves. This is a dx value. So now looking at a dy value, here I have this problem done in two different ways. Number 27, we have these two really basic, y equals x is the increasing function and y equals 2 minus x is the decreasing function. If we are to do this problem as a dx function, where we're using x as our home base, we would need to do two separate integrals. We would need to do this blue integral first, which is a triangle, the integral of x from 0 to 1. We then would need to add to that this very separate area, which is the integral from 1 to 2 of the purple graph, 2 minus x. We would add those two areas together to get that whole triangle. Opposing that, we can do this as a dy function, which is what the book suggests. Both are fine. It doesn't matter if your brain works better one way or the other. However, we do need to work into the dy's here as we get into 7.2 and specifically 7.3. And those are our last two lessons. So if we look at this as a dy function, we kind of have to rotate our screen. So as we are rotating our screen, think of, if I'm looking at this, where is the base? Okay, so if I run them this way, where will these little rectangles base off of? They will base off of the y-axis. If the rectangles are headed towards the y-axis, it's a dy function. Okay, so over here we have the top function, or sorry, in this problem over here we had the purple minus the red, the top minus the bottom. Well, as we're looking at this one, from y, if I'm thinking y is the bottom here, what's the top? That would be the green equation. And then I'm gonna move myself here. I'm flying. The top equation is going to be this green one because that's the furthest from the y-axis. The bottom is going to be the yellow function. So the top function minus the bottom function gives me y equals 2 minus y is the top function, minus the bottom function is the yellow function, which is just y, because y equals x. So you have to solve them for x equals instead of y equals functions. Then it is a super easy integral. We have bounds of y values. The lowest y value is 0. The highest y value is 1. So you have to kind of look at it sideways. I know it's really hard to visualize. But the lowest to the highest y value is 0 to 1. When you integrate that, it becomes super easy, and that will give us the area that we're looking for. And it will be the same if you integrate it in two separate triangles. Okay. Number 49. Looking at this one, the book did something a little bit wonky. We have, again, if you can look at this, we have two symmetric trigonometry functions as long as you're going from those origin points are very symmetric. So 2 sine of x I have in dark blue minus tangent of x in the red. These are both symmetric around the origin. Okay, I'm going to move myself again so you can see everything. Ha! Both symmetric around the origin. So we can assume then, because of their symmetry, that they have the same area on the left as they do on the right, which is why they said that there was 2 of the integrals from 0 to pi thirds. Now, if you're just not quite sure of this, there's a simple solution. You can do them separately. Do the integral from negative pi thirds to 0. The tangent function would be on top, minus the blue 2 sine of x function on the bottom. And then you're going to add to that the integral from 0 to pi thirds of 2 sine of x on the top minus the tangent function on the bottom. You will get the same area. This is not an integral that I'm expecting you to do off the top of your head. With being at distance learning, you are going to have open notes, not open internet, but open notes for everything. So this is one of those problems that I would expect you to be able to look on your chapter 5 sheet and get the integral of a tangent is the ln of cosine of x. So that's where we're at. Yes, and then this would also be a calculator function. That is good. You could also do a dy function, which would be really tricky, except you'd have to use arc sines and arctangents, and that's kind of nasty. But if you wanted to, you could, if you really like that. This one is just a review question. Not hard necessarily, but it wanted you to do the area as a trapezoid rule and a Simpson's rule as well. So in your trapezoid rule, there are 1, 2, 3, 4, 5, 6. Six was the height in between each of these barriers. And then we always have 1/2 times the height and then the average of the bases. So we have 0 would be the left base, and you have 2 of everyone in the middle, and then again 0 would be the right base. So that's how that comes to be. In the Simpsons rule, again, I didn't teach you the times 10 divided by 10 thing. So just pretend it's just your 6, because that's again your height. And then this time we're dividing by 3. That's part of the Simpsons rule formula. Left bound, and then it alternates 4, 2, 4, 2, 4, 2 in the middle. Not something that we really need to focus on, but just trying to keep this kind of in the beginning of your brain. All right, so, and you can add those up. You should get around 60. The last one is number 91, and this was this was kind of just a math modeling program, a real life problem that the setup was pretty easy. We have our top function, I think, of income minus our bottom function of expenditures. So when you combine like terms, your middle, these completely go away. We have 0.58 minus 0.45, which gives you just that. It's a super easy integral. We just need to take your 13 to 8, and then you have your value there. But I don't do a lot of word problems in the book, so I wanted to just go through that. If you have any other questions, please send me an email, post it on the Google Classroom page. If you have a specific question, I don't know how to do this problem, I will post a solution online. It takes me 2 to 3 minutes. Let me know what you have questions for, but we will start 7.2, which is going to be like a 5-day lesson on Wednesday. Good luck, everybody. Have a great day.